Now let's go through a quick demonstration of a UDP datagram. And again, I want to emphasize that the diagrams that you see of the architectures of datagrams and segments and packets and so forth are just conceptual. Sometimes it's hard to get your mind around it, so it's much better to look at how the traffic capture looks and how the network actually sees this traffic. So we're going to look at a UDP datagram, a couple of datagrams, and I want you to pay attention to the fields that we see here in the diagram, the source port, destination port, and data and so forth, and you'll get a better idea really of how UDP works. So let's go ahead and look at our demonstration. Okay, we're looking at our Wireshark capture again, and this time I want to show you a DNS query. Now DNS uses UDP as its protocol, so you'll get a better idea of how UDP actually works by looking at a DNS query. Now if we look at in our center pane here, we've got how our protocols are stacked up, and as you notice, these actually follow through with the OSI model. You've got the data link layer, the network layer, and then up here as a transport layer we have the user datagram protocol. Let's take a look at it. Let's expand this out, and these are the fields that we've seen for the UDP datagram in the diagram that we saw earlier. We've got the source port, which is 1031, the destination port, which is 53. DNS always uses 53, okay, and it uses both TCP and UDP as a matter of fact. Some parts of DNS use UDP and some parts use TCP, but they all use 53. Whenever you see 53, that's DNS. Here's our length of the datagram itself, and here's our checksum. Now, as we said before, UDP does not really worry about error corrections. However, it does have built-in checksum fields, so there is that, and that can be calculated and resent if necessary. Now let's look at our data field for the UDP, and that is actually the DNS query itself. So this is what's contained in the data part of the UDP datagram. It's basically a DNS query. The computer is asking to map a DNS name to an IP address. And here their flags are set, and here are the queries that we can see as well. That's what we're looking for. This DNS query is for VTC.com, and it wants to know which IP address belongs to VTC.com, because remember, computers deal in IP addresses, not necessarily domain names. That's what human beings read. So in any case, the DNS query is sent out over UDP. Now here is a DNS standard query response, okay, and that's coming from a DNS server itself. And you've got the UDP datagram, of course. Source port is 53. Destination port, again, is back to 1031, which was the original source port that it was sent on, that the query was sent on. Source port 53, destination port, the length, the checksum, and what was the response? The DNS response, basically, if we look down here, it's giving us some overhead information about the request. And here's our queries. That's what was asked. And here are the answers. And the answer was that the question was, what IP address is VTC.com? And that's what the first DNS query UDP datagram went out as. The answer, the reply back, was VTC.com is at address 66.160.128.92. And it also lists the authoritative name servers for VTC, and then there's additional records out there as well that the DNS query comes back with. The different domain servers and so forth, the reverse addresses and things like that. So there's a lot of data that actually comes back in a very small UDP datagram, and DNS carries a lot of information when it replies back. So that's essentially two examples of DNS datagram, or of user datagram protocol units, UDP datagrams. And as you can see, they're very simplistic data units, only 4 fields, 2 of them not even required. But they're very simplistic, very easy to read. And I would definitely get familiar with both the TCP and UDP segments and datagrams construction so you can better analyze this traffic when you see it come across your network.